Hello and welcome to this video on statistics and probability for further engineering mathematics at level 2. So some more data analysis. So what we're going to cover are statistics. We're going to work out the median from a cumulative frequency curve, the interquartile range from a cumulative frequency curve. Then we're going to look at probability, an introduction, the bell curve, and normalizing data. And then we're going to finally go through an example. So we're going to bring back the data we used in the statistics video. The only thing we're going to change is I'm going to, instead of having my F times V and S times V squared columns, I'm just going to have a cumulative frequency column on the right-hand side, as you can see. And you always just want to make sure that your final cumulative frequency value is the same as the sum of all frequencies. So you can see here they're both 40. So next up, we're going to put the midpoint and the cumulative frequency into a graph. This is a scatter graph. And then we're going to find the curve that fits this the best. And it should always look something like this. It's not perfect, but it's quite difficult to do on a computer. It's easier to do this by eye and hand. So with that curve in place, we can find the median and the interquartile range. So we're going to start with the median. So we've got 40 data points. And as we're taking the median from a graph, we just need to half this number and then add that point to the graph by doing some lines like this. And where it intersects our horizontal axis, our independent value, that's actually going to be our median. Here it's roughly 27 miles an hour. To work out the interquartile range, we need to take a quarter of the data first. So if we've got 40 points in total, that's going to be 40 divided by 4, which is 10. And then I'm going to add a line across and down from 10. And then I'm going to take another one at 3/4 of the data. So I'm going to take that 10 that I just worked out, times it by 3, which gives me 30. So I'm going to come across and down on my graph. And then what I need to do is calculate this width here. So I'm going to take the X value of my 3/4 and subtract the X value of my 1/4, which is that. And that gives us 7.5 miles an hour. So that's the interquartile range. It's quite straightforward. So we're going to have a look at probability as well. So here's a quick introduction. The total probability of all things happening in a scenario is 1. So let's take a coin being flipped and landing on the floor. It's either going to land on heads, it's going to land on tails, or it's going to land on its side somehow. So we can say 1 is equal to the probability of it landing on its heads, plus the probability of its landing on tails, plus the probability of landing on its side. So for instance, let's just say the probability of landing on heads or tails is 0.49999 and 0.49999 respectively. We can work out the probability that the coin will land on its side. 1 is there. If I substitute in my values for the probability of it landing on heads and the probability of it landing on tails, I can add those two values together. I can subtract it from both sides to give me the probability of it landing on its side on its own, which is that. So there we had the total possibilities were it landing on its head, its tails, or its side. So all those possibilities had to add up to 1. So by having a known value for the probability of it landing on heads or tails, we could work out the probability of its landing on its side. In actuality, it's much, much, much smaller than that, but these numbers seemed a bit easier to use. So probability and the bell curve. So the bell curve shows us the probability of something happening with the average values being the most frequent. So at 0 standard deviations from the mean, and trading off either side symmetrically towards 0. And it gets to 0 usually between 3 and 4 standard deviations. So knowing that all the outcomes of a test will result in a value under the bell curve, and by knowing that the value of all possible outcomes in probability is 1, we can say the total area under a bell curve is 1. Now, the probability table of a bell curve. Now, this table has an awful lot of numbers, but it's quite straightforward. The first column on the left, it says the first part of how many standard deviations from the mean we are. So 0.1, 0.5, 0.1. And the top row tells us what second decimal place to add to that. So if I wanted to get 1.55 standard deviations, I would come down to 1.5 and across the top to where it says 0.05, and I would end up here. So the value we get for 1.55 standard deviations is the probability of it landing between the mean value and the desired outcome, going in a positive direction. And it's symmetrical, so it would be the same for negative as well. But here we've got 0.4394. So the probability of us picking something at 1.5, of something being at 1.55 standard deviations is 0.394. So we're looking at this bit here where the arrow is pointing on this graph. So when data is normalized around the mean as opposed to 0, because we were on 0 on that last graph, we need to add a bit of formula to calculate how many standard deviations we need to be away from the mean. And here we have the standard deviations of the probability, sigma z, equals a minus x bar divided by sigma. So x bar we know is our mean, sigma we know is our standard deviation, and a is our target value we want the probability for. So let's work through an example. What is the probability of a car traveling less than 36 miles an hour, given the data that I've already had and used in the last statistics video? So sigma z is equal to a minus x bar divided by sigma. We're going to substitute in the numbers. So 36 miles an hour becomes my a. 29.375 miles an hour is my mean, and 5.61 miles an hour is my standard deviation. Let's solve the top, then divide. So that's the point I need to look at to get the probability. We look at the table and we find the value from 1.18, and we get that the probability is 0.3810. So we know the total area under the curve is 1, and we know it's symmetrical, so that the negative side of the curve must have an area of 0.5. The total area, which is directly proportional to probability, is then 0.5 plus 0.3810, which is 0.8810. So that's the total area less than the value that we want. If I need to calculate how many cars will be, that will be out of 40, we multiply the sum of the frequencies, then round that down to the nearest whole number. So the number of cars is equal to 40, which is our total number of cars, multiplied by the probability, 0.8810, and that gives us 35.24 cars, which doesn't exist, so it's going to be 35 cars. Hope that's helped. Thanks for watching. I'll speak to you again in the next video.